This is question 28. Feel free to pause and give it a try. Okay, so this is how I solved this question. So firstly, ABCD is a parallelogram where B lies on straight line CQ. So from this we can deduce that AD is parallel to CQ because B lies on top of straight line CQ. Okay, so we also notice that EQ is a straight line, and with this information we are able to find two sets of similar triangles. Firstly, we can see AEF and FQC are similar. This is because angle AFE is the exact same as angle CFQ due to them being straight lines. Also, AEQ is equals to CQE because AE is parallel to CQ. With this information, we can deduce that triangles AEF and FQC are similar. Similarly, we can see that angle APE and angle BPQ are the exact same, since EQ and AB are straight lines. Furthermore, we can also see that since AE is parallel to BQ, so angle AEQ is equals to angle BQE. Hence, triangles AEP and PQB are similar. Also, we can notice that since AE is equals to BQ, these two triangles are actually congruent. So what do we do with this information? Well, we can use it to solve our question now. So what the question is asking from us is to find 6 times AC over AF. And so we can rewrite this as 6 times AF plus FC over AF. And notice that AF over AF is just 1. So we're just trying to find 6 times 1 plus FC over AF. And from our first set of similar triangles, we know that FC over AF equals to QC over AE. So we can rewrite this as the second line. And do note that you also have to change the first AF to AE, as this must be equals to 1. And now we have AE plus QC over AE. Now, we can't just find QC, so we have to split it up even more. So we have QC equals to QB plus BC, so we just split it in the next line. And now we also know that QB is equals to AE, as AP and PQB are congruent. And BC equals AD as is a parallelogram. So now we just have to sub in values where AE equals 3 and AD equals 9. And we get that this is all equals to 30. And this is the answer. Now this is question 29. Feel free to pause and answer the question. This is my solution to this question. So originally I saw this 5 and was pretty confused as it was the only 5 and it really stood out to me. But then I realized that 5 is equals to 1 times 5 and can split this up into 3 minus 2 times 3 plus 2, which is quite interesting. So in the end we get 3 minus 2 times 3 plus 2 times 3 squared plus 2 squared all the way until 3 to the 2 to the n plus 2 to the 2 to the n. And if you can recall, we have difference of squares in play here. So a minus b times a plus b is equals to a squared minus b squared. So as you can see, we can combine the first two terms, 3 minus 2 times 3 plus 2, and we can get 3 squared minus 2 squared. And then we can combine that with the next term, which is 3 squared plus 2 squared. We can combine it and it will become 3 to the 4 minus 2 to the 4. And you can see where I'm going here. Ultimately, if we collapse hard enough, we get 9 to the 2 to the n minus 4 to the 2 to the n. And this must be greater than 9 to the 256. And you can see here that 256 is actually equals to 2 to the 8. So we must find the smallest n such that 9 to the 2 to the n minus 4 to the 2 to the n is strictly greater than 9 to the 2 to the 8. So since we have an 8 here, we can try subbing in n equals 8. So we have 9 to the 2 to the 8 minus 4 to the 2 to the 8. And as you can tell, it's pretty obvious that this is strictly greater than 9 to the 2 to the 8. However, we can try increasing it by 1. So we have 9 to the 2 to the 9 minus 4 to the 2 to the 9. And we can bring out a 9 and a 4 respectively to get the next equation. And we, we can employ a trick here. So we get, since 9 to the 2 to the 8 is strictly greater than 4 to the 2 to the 8, if we put a negative sign on both sides, we know that negative 4 to the 2 to the 8 is strictly greater than negative 9 to the 2 to the 8. And we can use this inequality to get the next line. And by subtracting both terms, we get 5 times 9 to the 2 to the 8, which is strictly greater than 9 to the 2 to the 8. And hence we can prove that this term on the left hand side is strictly greater than 9 to the 256. So we can deduce that the smallest positive integer n is equals to 9. Now this is question 30. Feel free to pause and attempt the question. Okay, so this is my solution to this question. The question asking us to find the shortest distance a person needs to travel so that he will walk through each path at least once and return to the starting position. This is very important, as you will notice that the number of times you enter a point is equal to the number of times you exit the point. However, you can see that on the edges of this lattice, there are 10 points that do not fulfill this criteria, as the number of times you exit a point is not equals to the number of times you enter the point. We can connect these 10 points up with 5 imaginary lines that can be thought of as just walking backwards. And now each point on this lattice has the same number of entering and exiting lines. Now you can just pick any point to start off from, and if you carefully trace the line out and make sure to walk through each path only once, you'll find out that the minimum number of lines is 38, which is 38 meters. This is question 31. Feel free to pause and try out this question. Okay, so this is my intended solution. So you can see that ax plus by equals 40, and then you increase powers of 2, then 3, then 4, and so on. And the equation linking all of them together is as follows. And once you get this equation, everything else is pretty simple. You just sub in the values. So you get 3 equations: 110x plus y equals 310 plus 40xy, and 310x plus y equals 890 plus 110xy. And from these two equations, I'm pretty sure you know how to solve simultaneous equations. So you get x plus y equals 5 and xy equals 6. And the important thing is that you don't actually need to solve for x and y, even though pretty sure you guys know that it's 2 and 3, because all we need is x plus y and xy to solve for the following value. So lastly, to solve for ax to the 5 plus by to the 5, we just do another equation. This time 898 x plus y equals ax5 plus by5 plus 310xy. And then we can sub in the values and get the following answer. Okay, so this is a tricky question. Feel free to take your time to solve it. Okay, so this is my solution. Firstly, we have to notice how 9 is the smallest composite prime number. And this is really useful since we are finding the sum of 3 composite odd integers. And using a smallest number will result in us getting a larger number of numbers within a certain range. So now we have to find k, the largest k that cannot be expressed as the sum of 2 composite odd integers, and then we'll be able to find what k plus 9 is, which is the answer to this question. So in order to find k, what you have to notice is that 15, 25, and 35 are the next few composite odd integers after 9. And this actually helps us because if we decide to split k up into 3 cases, when it's divisible by 3, when it gives a remainder of 1 or gives a remainder of 2, we can see that k equals to 15 plus 3n, 25 plus 3n, and 35 plus 3n, respectively. And this works because 15, 25, 35 are all composite odd integers, as I said, and 3n is also a composite odd integer as long as n is a positive integer greater than 1 and n is odd. So we can see that the largest k we can attain from that fulfills this criteria is actually 35 plus 3n when n equals to 1. And this is equals to k equals to 38, and hence the largest k plus 9 equals to 47, which is the answer. This is question 33. Feel free to pause and try this question out. Okay, so this is how the question is going to be solved. The question mentions the use of a regular decagon, which is a 10-sided polygon. And if you have the formula, you can find out that the interior angle in a regular decagon is actually 144 degrees, and half of that is just 72 degrees. And we can also notice that this decagon can fit inside a circle, and there are many properties of a circle that we can use, such as this over here, which is, notice that SP is the diameter of the circle, so angle SRP would be 90 degrees as SP is the diameter and R lies on the circle. And by forming a triangle RSP, we can find out angle RSP is 18 degrees. Here comes the slightly harder part, which is finding angle QSP. If we connect point S and Q, we can notice that there's a triangle in the top left hand corner, and since it's a regular decagon, we can find out that one side is actually 180 minus 144 over 2 degrees, and QSP is just 72 minus that. The 72 comes from half of 144 degrees, and we get QSP equals to 54 degrees, and by the same logic, angle SQP is 90 degrees, and angle QST is actually just 54 minus 18 equals 36 degrees. And if we add those two angles up, we get 36 plus 90 equals 126 degrees due to exterior angles, and that is just x degrees, which is angle PTS, which is what we're finding. This is question 34. Please feel free to try this question out. Okay, so this is how I solve this question. So this question actually uses the Pythagorean theorem. So let's connect O to B, so we can form a triangle OAB. And since AB is tangent to circle O, we know that angle OBA is 90 degrees. So this fits the Pythagorean theorem, so we can find length AB, which is just square root of 15 squared minus 9 squared, which happens to be 12. And speaking of tangents, there's another property of tangents is that it has equal lengths if they are from the same point. So since point A is the same as point A, obviously, so we know that AB equals to AC equals to 12. And we can also find out that PB equals PR and QC equals QR. Now we just have to plug that all in to find the parameter of APQ, which is just AQ plus AP plus QP. And we can just split it up further, and if we simplify further enough, we just get this is equals to AC plus AB. And we also found that AB equals to 12 and AB equals to AC. So we just know that AC plus AB equals to 2AB, which is 24. Okay, so this is the last question. Feel free to try it for yourself. So this is how I answer this question. So firstly, with this information, what you're meant to do is extend line AB to S such that S touches the circumference of the larger circle. And what this gives us is that there are now 4 points on the circumference, S, Q, B, and R. And what we do with this is that we can notice that angle QSB equals to angle QRB. This is because with two fixed points, Q and B, any third point placed on the circumference will give the same angle. And notice how QRB equals to angle PRB because P lies on QR. Next, we can also notice that angle SQB equals angle RQB because they are all on the circumference. And this is also equals to 90 degrees as due to the properties of circles. And with these two information, we can see that triangles QSB and triangles PRB are similar. And then we can have the ratios of the sides. QB over SB equals to PB over BR. Now we're trying to find QB times BR, and we know that this is equals to SB times PB, and if we multiply them together we get 200, which is the answer.